Hi. So in this last section, we're going to discuss more involved probabilities. In fact, these are my funnest examples because it's all about winning the lottery. And so we always think like, oh, people are so lucky when they win the lottery. And where does this word luck come from? Well, to mathematicians, luck it really means a really small probability, close to impossible. And so we're going to see winning a lottery is close to impossible, which means we kind of feel lucky when we win the lottery, right? And how could it not be luck, right? So let's go ahead and take a look. The first one is in a certain state's lottery, 48 balls numbered 1 through 48 are placed in a machine and 6 of them are drawn at random. If 6 numbers match, the player wins $1 million and all 6 have to match to win the $1 million prize. What is the probability of winning that $1 million prize? It's very exciting. Okay, so let's go ahead and think about this. So here, does order matter? When they pick the 6 numbers, is it a certain order they pick it? And does your ticket have to match that order or just match the numbers, which could be in any order? That's right, it just needs to match the numbers and not necessarily the order of the numbers. So here, order doesn't matter. And that can numbers have with replacement? If the machine picks out number 23, will it pick out number 23 again? No, once that ball is taken out, you cannot pick it again, right? So it is without replacement. So when we know all that order doesn't matter is without replacement, we automatically know that it's combinations. Okay, some other things we need to note, that we have 48 numbers to choose from, and we need to pick 6 correct ones to win the prize. Okay, I think we're ready. So the probability of winning is equal to the number of ways you could win, meaning match 6 numbers, all over the total number of ways you can just choose 6 numbers. Remember that the numbers aren't going to, you can pick 6, it doesn't mean you have the winning ones, right? So you need to find the number of ways you can actually see that event occurring, meaning match those exact 6, and then out of the total number of ways you could just pick 6 numbers out of 48. Okay, so here, if I want to match the numbers, then I just need 6 of the winning numbers, choose exactly 6 correctly. So out of the 6 that I need to choose, 6 of them have to be exact. Okay, out of how many ways we can choose 6 numbers? Well, how many numbers do we just have to pick from, right? 48. And we only choose how many? 6. So really here, if it's just 48 balls, we're just choosing 6, right? But to pick the winning number, it has to be exactly the 6 numbers that are exact, right? Okay, so if we do this, we could put this in the calculator and put math, probability, and then 6 choose 6. And if you do 6 choose 6, you'll see that the answer is 1, because there's only really one way you can pick 6 correct answers out of 6 choices, right? So 1. And then we could go ahead and hit math, go to probability, and do the denominator, which is 48 choose 6. And that'll be 1, 2, 2, 7, 1, 5, 12. Okay, and if I wanted to do this as a decimal, you'll see how small this is. It is 8.14895, and so on, -8. So remember, the -8 means I'm going to move 8 decimal places to the right. So I would do approximately 0.0000008,149. And that is a really small percentage. In fact, the fact that the chance of winning is less than 1%, we call this event unusual. So that's really the thought, is the fact that the event is of the chance of winning is so low that the fact that someone would win, it would be unusual. And that is less than 1%. Now, and according to like the rule of thumb, it's usually if it's less than 5%. So even having it less than 1%, that's even more unusual than we expect, right? And that's why it's so close to zero, it's almost impossible to win. So when people win, it's, really lucky. Okay, so now you're like, I don't need to win it all. I can just win a little bit of it. So now let's go ahead and look at winning the lottery of a second prize, right? Some of us, we're not that greedy, right? I'd be happy with just a few million, right? So in the state lottery from the previous example, so we're still picking out of 48 numbers, 5 of the 6 numbers are drawn for second place, and then you can win a little cash for that. So let's find the probability of winning second place, which means you only need 5 of the 6 numbers to win. Okay, so again, we know from above that this is going to be a combination. Okay, and then we still have the 48 balls, but let's think about this. How many balls need to be correct? Not all 6 this time, right? Only 5 of the 6 are correct. And 1 can be incorrect. Okay, well, the probability of winning second place is equal to the number of ways we can match 5 numbers over the number of ways we can choose, well, 6 numbers in general, right? So matching 5 numbers, recall that that means that we're going to match 5 and then 1 not matching. Okay, well, let's think about this. So if we want to match 5, how many correct numbers do we have? Right, we have 6 correct numbers, and we're only going to choose 5 of them to match. And don't forget, so 5 of the 6 are correct. And 1 is incorrect. How many numbers are incorrect? Well, if we have 48 numbers, 6 of them are correct. That only leaves 42 to be incorrect. So out of the 42 numbers left to be incorrect, I'm choosing 1 to be one of those 42 numbers that aren't going to match. And so I'm going to divide this by, and the same thing, the number of ways I'm just going to choose 6 numbers, which is 48, choose 6. So again, if you're going to match 5 out of the 6, then you're going to have, right, then you'll have 1 not matching, and that means 1 is incorrect. So if you look here, the 5 plus 1 is the 6 numbers you're picking, and the 6 plus 42 equals 48, the total numbers that you have to choose from. Okay, so if we did this in the calculator, you'll see here that we get, I'll put parentheses, I'll do it all at once so you can see something. So I'll put combination 6 choose 5 times, times, again, go to math, prob, and then number 3, and then do 42, choose 1, get out of the subscript and close the parentheses, divided by math 3, and 48 choose 6. Okay, and hit enter. And now you see the small number. This is going to be this number to the -5, meaning I'm going to move the decimal over 5 times. So I'll have 0.00002054, right? Which is pretty small. And you notice that when I want to put it in a fraction, it won't, because it's just too much to handle. But if you want to use more robust calculator engines, you can. Like, I'll show you one that I always use. It's called Wolfram Alpha, and you can put in this search engine combinations, and then they'll give you the reduced fraction all the way to the decimal. So let me do that here. So I'll put parentheses, combination of the first one, which is 6 choose 5, times the combination of 42 choose 1, close the numerator, so you see it highlights and everything, divided by combination of 48 choose 6, and hit enter. So it's calculating stuff, you can see here. And so notice it does give you that decimal approximation we got, which is 0.000205 right? And then it also gives us the exact results, which is 21 over 1,000,000 22,626. So if you use more robust computational engines, you can get the fraction that you need even though your calculator isn't as robust. There are robust online calculators out there that you can find the information. So it's really up to you. If the problem asks for the answer of a fraction, then yeah, you'll want to probably go to this website or the app and do it here. But if it's just a decimal approximation, your calculator can always do that. So either way, you should be able to get the results, whether as a decimal or fraction. But in this case, we could see that the probability of winning is still really low, right? We thought, oh, second place, we're going to get it. We're in it, right? But if you look at it, it's still less than a 1% chance, right? It is actually 0.002% chance. So this is still, the chance of winning is still less than 1%, right? And it's still unusual to win. So even if you won second place, that's still really lucky. Okay,